All right, let's dive into a story that is honestly one of the most incredible testaments to modern medicine. We're talking about congenital heart defects and how our entire approach to this has been completely flipped on its head over just the last few decades.
So how common are we talking about here? Well, the number is probably going to surprise you. Get this, about 1 in every 100 babies is born with some kind of heart defect. That's almost 1% of all births, everywhere in the world. It's way more common than most people think.
And that really puts the scale of this challenge into perspective. Yeah, this isn't some rare, isolated condition. We're talking about the single most common type of structural birth defect in the entire world. Period.
But this is where the story takes an absolutely incredible turn for the better. I mean, thanks to some mind-blowing advances in medicine, in a lot of countries, more than 90% of kids born with these defects now make it to adulthood. That is one of the biggest success stories of the last 50 years, for sure.
So that survival rate is amazing, right? But it brings up a really crucial question. Survival is the first huge win, but it's definitely not the end of the road. So what happens next? What does that lifelong journey actually look like for these survivors?
Okay, so our first section gets right into that. It's about this hidden global challenge, how we've gone from dealing with a neonatal crisis to managing a lifelong condition.
And check this out. This is a total demographic flip. For the very first time in history, we have more adults living with congenital heart defects than children. I mean, just in the US, we're talking 1.4 million adults. All those kids we successfully treated, they're grown up now, and that's created a whole new world of medicine.
Okay, so to really get what these lifelong challenges are all about, we gotta understand the basics of the defects themselves. Let's break it down with a really simple but super helpful concept: pink babies and blue babies.
Okay, so it really all comes down to plumbing, which way the blood is flowing. For acyanotic, or pink babies, you've got what's called a left-to-right shunt. Basically, blood that's already got oxygen gets sent back to the lungs. So the problem isn't a lack of oxygen, it's that their lungs get flooded and congested. Now for cyanotic, or blue babies, it's the opposite. A right-to-left shunt means that blue, deoxygenated blood skips the lungs entirely and gets pumped out to the body, and that's what gives them that bluish color.
And here are some of the most common examples, just to make it a bit more concrete. On the pink baby side, you've got things like a VSD, a ventricular septal defect, which is basically a hole between the heart's main pumping chambers. Then for blue babies, the defects tend to be more complex. Things like tetralogy of Fallot, or, get this, transposition of the great arteries, where the body's two main pipelines are hooked up backwards.
So what actually causes these defects to happen in the first place? Well, a good way to think about it is like a super complex recipe for building a heart. All these different ingredients have to be added at just the right time, in just the right way. And we're still figuring out exactly what happens when that recipe gets messed up.
And this chart gives us a pretty good idea of those ingredients. About 35% of the time, we can point to a specific genetic cause. Another 10% seems to be linked to environmental factors. But look at that big slice. Over half the time, it's a total mystery. It's some complex mix of genes and environment that we just don't fully understand yet. So let's break down some of those known risk factors. Genetically, you've got things like certain chromosomal conditions, but maternal health plays a huge role. For example, if a mother has diabetes before pregnancy, it can triple the risk. Then there are things like infections, like rubella, substance exposure, and that includes from both parents, and even things like air pollution. Any of these can throw a wrench in the works during that critical development phase.
Okay, so we've got an idea of the causes, but how do we actually find and fix these hearts? Well, the modern toolkit we have is nothing short of incredible. But, as we're about to see, that care comes with a pretty hefty price tag.
All right, to really get the economic picture here, let's start with this number. Kids with congenital heart defects, they make up about 4.4% of all hospital stays for children.
Okay, 4.4%. But that same small group of kids accounts for almost a quarter, 23%, of the total cost of all pediatric hospitalizations. That is staggering. It just shows you how specialized, how intensive, and how expensive this life-saving care really is.
So the key is finding these things as early as possible, right? Well, one of the coolest breakthroughs is happening in diagnostics. We're talking about AI-powered ultrasounds. These things can help doctors spot defects way faster and more accurately during a routine pregnancy scan, even if that doctor isn't a top-tier heart specialist. It's a total game changer for getting that early diagnosis.
And when it's time to actually fix the heart, there are basically two main paths they can take. The first is called catheterization. This is a minimally invasive technique where doctors can thread tiny tools through blood vessels to do things like plug holes or place stents. But for the really complex defects, open heart surgery is still the only way. And often, it's not just one surgery. It's a series of planned operations over the first few years of a child's life. And you know, all that success, all those mended hearts, it brings us right to the new frontier. And that's the lifelong journey. We're talking about the unique challenges faced by this huge, growing population of what we call adult congenital heart disease survivors.
So, for these adults who survived, what's the single biggest risk they face? I bet the answer isn't what you think. It's this: just losing touch with their specialized doctors. It happens all the time. When they age out of pediatric care and have to move into the adult system, it's really easy to fall through the cracks. And the thing is, their hearts aren't normal. They need lifelong monitoring by experts who understand their specific plumbing. A regular cardiologist just isn't enough.
And falling through the cracks is incredibly dangerous. Look at this. An adult survivor who has a care gap of just 2 years is 3 times more likely to need an urgent emergency procedure later on. Staying plugged into that specialized care network is absolutely 100% critical.
And this really drives home the point that even with a fixed heart, the problem isn't over. Living with this is a systemic, whole-body condition. These survivors face much higher risks of things like irregular heartbeats, premature heart failure, and even problems with other organs like Fontan-associated liver disease. And as you can imagine, dealing with all that takes a huge toll on their mental health too. So let's wrap this up by looking forward. Where is all this heading? Well, the goal is shifting from just treating these defects to maybe, one day, actually curing them. And that brings us to what some people call the holy grail of this field, regenerative medicine.
Okay, check this out. One of the most amazing ideas being worked on is the concept of living valves. The idea is just revolutionary. So, step 1, surgeons transplant living donor valves into a baby. Step 2, because that valve tissue is alive, it grows right along with the child. Which leads to step 3, this could mean no more repeat open heart surgeries just to replace parts that the child has outgrown. That would change everything.
And that brings us to the big, final question. For half a century, the entire goal was simple: save the child. And we've gotten incredibly good at it. But the new challenge, the question for this next chapter of medicine, is different. It's, now that we can save the child, can we build them a heart that will last a lifetime?